Look, my name is Nagraj. Currently, I have 14 years experience in performance testing. And the interesting part is a lot of people start as a functional tester and then they might move to performance testing. But in my case, I started as a performance tester. So
Okay.
because of that, whatever 14 years experience I have, everything is in performance testing and performance engineering space only. And
So
during
when you
Mhm.
started your career?
So 2009, 2010, yeah, 2010.
Okay,
Mm.
I started in 2007 with Cognizant.
Okay.
Yeah, as a manual tester, and then I switched to automation from there on. Yeah,
So
so
yeah,
you started in India. Like I would like to know
yeah,
like where you started is
yeah.
your city and
So my first job posting was in Pune.
okay, yeah. I also worked from Pune actually. I am
Mm.
basically from Pune in Jodi.
Yeah. So I was with Tech Mahindra when I first started. So
Okay,
Tech Mahindra office was in Hinjawadi office. Yeah.
okay.
Mm.
Yeah.
So that,
So after that, like you did your education in which city?
so I was born and brought up in Karnataka. So my engineering was in KGF, Kolar Goldfields. So that is where I did my. I was born in KGF, and my engineering college, all complete education happened. Almost all graduation, college, everything happened in KGF, Golden Valley Institute of Technology.
And then you got placed to the campus placement, is it?
Correct, correct. Yeah, I got placed through campus.
Yeah.
When I was in third year, we got placed in Tech Mahindra,
Yeah.
and that's how the career started. It was a bit easy because we got selected in campus. Otherwise,
Yeah.
uh, it would have been tough, right? Mm.
Yeah, so all 14 years you are into performance testing. Like, did you think about switching your career or you were happy with performance testing?
No, we are happy. So performance testing is very interesting. Look, I'm a very curious person. If
Mm,
I'm doing something which is not challenging, I get bored
mm,
very quickly. So luckily, performance testing is not like it's not monotonous, right? It's always challenging. When you're running a test, you don't know what kind of issues will come, and you don't know where the issues will come. The issues can be at application layer, database layer. Issues can be in the network layer, so everything is like very curious, and it's good, it's very interesting. And luckily I worked in very good projects as well. So when I started my career, first year was not very interesting. It was a lot of learning and all, but the second year I worked in Cisco client. So it was like we got servers, we can play, we can do anything with it, and we have to do performance benchmark for those servers. So it was very interesting. We can play with configuration changes, and we closely work with database guys, we closely work with application teams. It was very interesting. That's how it started, and it continued actually even after I came to Australia. All the projects that we worked are very interesting projects. Even in Australia, when I came, we had to migrate a lot of applications from on-prem data centers to cloud data centers. So yeah, luckily I didn't get bored. Maybe if I would have got bored, maybe I would have changed the careers. But
okay,
yeah, it's
that's
doing good.
interesting. Yeah. So when you talk about this, like going from the on-premises to the cloud, like how do you see the changes in the performance? It gets better in the cloud, or have you seen like any circumstances where it might have backfired? Probably.
Look, initially we do a lot of testing, and only then
Okay.
we switch to the production, right? So initially, when we start, obviously we will have performance issues because when we go from on-prem servers to the cloud servers, the cloud server capacity will be different. The on-premises servers are those are physical servers, right? No one, we are not sharing our infrastructure with anyone. But the on cloud servers, even though they say we get unlimited servers and all, but even the physical server, it's all virtual environment. So physical
Yes.
servers will still be shared by multiple tenants. So the challenging part is having the right size of right number of servers, right type of servers. It's not just about having 5 6 servers. It is also about choosing the right type of servers for our applications, because Few applications will be memory intensive, so you have to choose EC2 instances on cloud which are memory intensive. Few applications will be CPU intensive. So these kind of things we can find out only after testing. So
Okay.
of course, when we start our testing on the cloud, we start with minimum number of servers. We will not start with 10, 20 servers, right? We might start with minimum 2 or 3 servers, and we might choose a small server to start with, and then we test and see how it goes. If the performance, if the performance results are as expected, then we go with it. If the performance results are not satisfactory, then we might have to change the type of servers or first play with the configurations. All these things will be there. After all the once we do all the testing and we know how many servers to have, what type of configurations to have, cloud is good. Like I don't see any reason why people should not move to cloud.
Okay.
So it's very flexible, and yeah, cost wise, you don't have, there's no upfront cost, right? Yeah, but we have to do some testing. Some level of testing is definitely needed.
Okay. So next question I would like to ask is about the tooling that you have used over the years and how it has evolved.
So when I started my career, we used to use LoadRunner. I think it's LoadRunner 9.5 or something. 9.5 version was there when we used.
Okay.
Now we have, I think it's 12.5 or 13 version we have. And LoadRunner we used a lot, and we also used JMeter a lot. These are the main tools I used. We used Silk Performer for very little time, but most of my career we were using LoadRunner, JMeter.
Okay. So with the JMeter, like we can do like API testing that kind of testing, right? But if you want to check the performance of the servers itself, in terms of memory and all those things, metrics. So is there a different tool for that, or it is the same one?
Look, JMeter is open source tool. It is a load injection tool.
Yeah.
So when it comes to performance testing, there are two things. So firstly, we need a tool which can inject the load.
Yeah.
So performance testing is all about load testing and stress testing, right? We want to know, even before the application goes live, we want to know how the application performs when, let's say, 100,000 people are using it. Or maybe we might want to know the performance of the APIs when 1,000 requests per second are hitting on the APIs. So the JMeter tool does is it just simulates the load on the server. That's all it does.
Yeah.
It is a load detection tool, and it does good. We can test APIs. We can also test UI applications. We can test JDBC, database SQL. So there are a lot of JMeter supports a lot of protocols. And once the load injection is done, then we need to collect the performance metrics. So after the load injection is done, we want to know how the backend servers are performing, how the CPU of the server is doing, how the memory of the server is doing. And not just CPU memory, and also application level details. We might want to know, if it is Java application, we want to know how the heap utilization is. All these things, we use extra tools, additional tools.
So my question is around those things, like injection of the load is fine. Like we can use JMeter and hit the
LoadRunner, JMeter,
but
the
main problem that I actually generally that question comes to my mind is like on the server side, sometimes we may not have access to the server, or as you said, in application level also we have to check those things. So sometimes we may not have access to those things. So how do you handle those situations, or it is important to have the access to those servers?
Yeah, it is important. So that's where I always tell people this, right? So when someone want to get into performance testing, so there is a career path in performance testing. So first we join as a performance tester. So the main roles and responsibilities of performance tester is just to inject load, get the reports. High level performance testers does not go too deep. But performance engineers are different. So performance engineers, they go to the next level. They get access to application servers log. They get access to the database logs like AWR reports, or they will have access to database to do explain plans and a lot of things. So basically, they will be more involved and they will work closely with the dev teams, database guys. So that's where we do performance engineering kind of things. So there are two different things: performance testing, where injecting load, collecting basic reports, and performance engineering is where getting access to application logs, getting access. Sometimes we also get access to the code as well. We will not make changes to the code, but we will have access to source code repository. Like when we are using Bamboo plans, anyone can get access to Bamboo plan. You can check out the code and you can check what developers have written, but there is we can't change, we can't make changes to the code because that's not our responsibility. But we can always look at the code, we can always look at the configurations, and we can suggest people or developers what to do.
You just
So basically, we have to get access. We use monitoring tools to do all this monitoring part. So we can use New Relic is a very good tool which people can use. Dynatrace is a very good monitoring tool which gives very good insights about the application database, everything. Dynatrace and New Relic are popular performance monitoring tools. And Cisco App Dynamics is also there. There are a lot of tools.
Heard about this Prometheus.
Prometheus.
Yeah, Prometheus. Sorry, yeah.
Yeah, Prometheus, Grafana. Yeah, a lot of tools are there. Open source tools are there. This New Relic Dynatrace is a paid tool. It's a licensed tool, but a lot of companies use New Relic. Dynatrace, App Dynamics are very good. We don't need access to backend, and all. Most of the details will come up in New Relic and Dynatrace. You can see application server details, memory statistics, JVM. If it is a JVM application, you can monitor the JVM heap and all that.
So
sometimes.
So my question is like, sometimes in cloud, especially, there is auto scaling thing, right? So it becomes difficult, right? How do you measure the performance? Because when the application load is increasing, they might launch another instance, and then how do you measure the performance in that case?
See, there are two things we can do. First, the approach what we follow is we will have a fixed number of servers. We will have fixed number of servers, and we want to test what is the maximum load this fixed number of servers can handle. Let's say we will start with 2 servers, and we will see how much load these 2 servers can handle. So that is one exercise which we do. Once we know how much capacity 1 server can handle or how much capacity 2 servers can handle, then we turn on auto scaling. Auto scaling can be turned on, or you can keep it off as well. It's configurable.
Yes.
And so once we do the first basic level of testing, then we turn on the auto scaling, and then we need to configure some parameters like at what point we need to add more servers. So the triggers for auto scaling can be CPU utilization or memory utilization. We can tell that whenever, let's say you're running with 2 servers to start with, and let's say average CPU utilization of these 2 servers is 70%. You can keep a trigger. You can say whenever average CPU utilization goes above 70%, you can tell AWS or Azure, whichever cloud platform you're using, you can configure in such a way to add 1 more server. So let's say you have 2 servers and the average CPU utilization is around 69%. And as soon as the average CPU utilization goes above 70, 1 more server gets added. So now we have 3 servers, right? So now because we have 3 servers, the CPU will come down from 70, it might come down to 40 or 45 because the load gets distributed between 3 servers now.
Yeah.
So these things we can see if we get access to AWS console, there we can see how many servers we have, at what time the 3rd server got added, and after the 3rd server got added, how the CPU utilization changed. Obviously, when we have two servers, if CPU utilization is 70, when we have 3 servers, it might come down to 50 or something because load gets distributed. So these kind of things we can check, and we can also measure. So the main objective is to see whether the main objective of auto scaling testing is to see if the auto scaling happens as per the triggers or not.
Yeah.
So that is one of the tests that we do. So first we do benchmark testing with fixed number of servers, and then turn on the auto scaling, and we slowly ramp up the load and see if the auto scaling is happening as expected or not. That is one more type of test. And we can measure the performance. We can see as the auto scaling is happening, you can see how the CPU is changing. You can also see when you have two servers in LoadRunner and JMeter tools, you can actually filter for particular test duration. Let's say you know from 10 o'clock to 11 o'clock, you know that you had two servers, and from 11 o'clock to, let's say, 11:30, you had three servers. You can, if you want to know response times when you have two servers, you can filter that. If you want to know the response time when you had three servers, you can filter that.
Okay.
Yeah, even in one test, even if you combine one test and run with the auto scaling on, you can still collect the response times and memory utilization, everything. But you should know the timings of when this auto scaling happened. That is the key.
Yeah.
If you know when second server got added, if you know when the third server got added, accordingly, you can take the metrics and break down the metrics, and you can measure.
Okay. And how is the knowledge of AWS, GCP, or Azure is necessary to work as performance engineer? I think it would be really important, right? Because nowadays everything is in cloud.
Yeah. See, it depends on type of projects we are working, right? If we are not working on, not everyone is on cloud. Yes, most of the companies are moving to cloud. That is true. And more companies might move to cloud in future. So knowledge about these cloud providers like AWS, Azure, and Google will definitely help. But if we are working in projects where the client is not using cloud, if all the servers are on-prem, then we don't need cloud skills, right?
Yeah.
It all depends. If we are testing something on cloud, it's good to have. But the fundamental concepts will be same. The fundamental concepts, if someone is learning performance testing on how to do performance testing on on-prem data centers, the principles will be the same. There will be few things they might need to know, like auto scaling, how to configure auto scaling, different types of auto scalings. And in cloud, you'll have different types of server types will be different.
Yeah.
So different types of server families will be there. All these things, it's good to know. It will, if you're working on cloud projects, and if you are not a performance tester, if you are a performance engineer, you have to know all this, because we should be able to suggest people, because the developers, not all developers will think like a architect. So they are good in writing code. They're very good in writing code, but they might not think in terms of infrastructure. They might not think in terms of best configurations. So we, as a performance engineer, because our main job is this, our main job is all about performance, good configuration, optimum price and performance, all these things. Our mind works differently. Developer minds works differently. So developers and performance engineers can work together. We can always recommend that, okay, we tested with this type of server, the results are not good. Why not test with a different type of server or different family of server? And we can also suggest configurations and all that.
Okay. And have you worked on can you give me example where it was very challenging, or there was huge load? For example, let's say Flipkart Billion Day or Amazon, there is specific day, right? Black Friday or something. On that day, there is huge traffic. So have you faced those kind of situations? Any specific thing that is in your mind?
Yeah, so we used to work in Telstra, right? So Telstra projects. In Telstra, Telstra has a lot of these iPhone launches and a lot of promotions they do. So we know that, during these promotions and during that Boxing Day sales, and also there are few applications like this, whenever this AFL happens, in Australia, the Telstra has some streaming subscriptions and all that. So obviously we will see more load on the application on the AFL related APIs, and also whenever this Apple sale happens, we know that there will be more load, but we will be prepared. We will simulate those kind of loads in advance.
Okay.
When we are doing performance testing, we consider all these things. So we call it peak load. So
Yeah.
we always, when we're talking with the business, we will always ask them what is the expected peak load. So they will give us, okay, we are launching during iPhone launches. They might tell us our APIs might get these many number of hits, and during AFL season they might say our peak load might be XYZ, right? They will give us peak load on APIs, peak load on servers. So
Yeah.
we simulate those kind of scenarios in advance based on whatever peak load business gives. We will simulate that, and a lot of rigorous testing happens in the back end even before the launch date. So we would have simulated that load in advance. That's what load generating tools like LoadRunner or JMeter does. We simulate the load in advance, and we know how many servers we need for that particular launch day, and we will not keep the servers on always. If you, let's say you're having only let's say 500 transactions per second you're getting load.
Yeah.
Just an example, you're getting 500 transactions per second, whether it is API or if it is a website, we measure in terms of concurrent users. Let's say on an average 1,000 users are accessing our site on an average.
Yeah.
But on the launch day, we know that 1,000 transactions per second might get generated on APIs, and we might have like 10,000 people accessing the site at the same time. This kind of, we call it non-functional requirements, and we call it as a peak load, expected peak load, right? We get the peak load from the business, and we would have tested it. So because we have already tested it, we know how many servers we need. We know what is the best configuration that we need to have. All these things, we know those things. We know how many servers we need, but we will not we will not start running those servers from now itself. If the go live, if that event iPhone launch or whatever is happening next month, just one day before, sometimes what we do, sometimes we let the auto scaling to happen.
Yeah.
Sometimes we know that when auto scaling happens suddenly, it might not scale up very quickly. So what we will do, we know how many servers we need to handle that peak load, right? So we will not start all the servers, but we might, let's say normally we have 20 servers. During those launch days, we might start another 5 servers or 10 servers in advance. So that we will start, and as soon as the event is done, we shut it down, we scale it down. So this is the advantage of having cloud. It's very flexible. You can start the servers whenever you want, you can shut down whenever you want, and you get you get billed only if the servers are running.
That's
so so this kind of, a lot of preparation happens in the background. So we don't always run with the peak capacity, peak number of servers required. Few servers, few additional buffers we might keep. And sometimes auto scaling happens as the load increases as well. And everything would have tested, and we have alerts configured as well. If something is,
just one question on this, like, let's say I have a server, and at certain point, like number of concurrent requests, how do you know like that server is breaking? Do you get like 500 responses, or what is that thing that helps you decide that server is started breaking or dying?
So as I said, performance issues can come at hardware level, which is a software, which is your CPU and memory limitations. Performance issues can also come at the application level. It can be configuration issues. So if when we are running the load test, if the CPU goes above, let's say if the CPU is reaching 100%, we know that the server is a bottleneck. Because it should not be 100%. It should, during normal times, we want CPU to be around 70% mark. 70% is a healthy CPU utilization. If the CPU utilization is going 100%, means we know that number of servers that we have are not enough. So this is the bottleneck is at the server level, right? Okay. And the 500 issues comes when the bottleneck, when the application, you can get 500 errors at 2 scenarios. Number one, let's say the server, the CPU capacity reached 100% and the application server crashed. And obviously, when your application server crashed and it's not taking any more load, you will obviously get 500 errors. So this is one scenario.
Yes.
And there is one more scenario where you can get 500 related errors, even though even though the hardware is not fully overloaded. I'll give an example.
Mm.
Let's say you have really very powerful servers, and the CPU utilization of the servers is just, let's say CPU utilization is just 50%.
Okay.
So CPU utilization is 50%, memory utilization is 50% because you have very powerful servers. So hardware is not a problem here. Even in these kind of scenarios, you can still get 500 related errors. So in those cases, so as soon as you look at the CPU and memory utilizations, you know that it is only at 50%. Then you know that it is not even though the CPU and memory is only 50%, if you're still getting this 500 errors and all, then you know it is not a server limitation. You know that it could be some software related issue. So
Yeah.
either some connection pool is not configured properly, or number of sessions might get throttled. So sometimes what happens is when application developers, when they deploy the applications, they might deploy applications with very default configurations. So default configurations for let's say you have a connection pool. If the default configuration is only 100 connections in that pool, if it can take only 100 connections, even though the server has a lot of CPU and memory capacity, because of the limitations on the application configuration side, it will just say, I'm not taking any more requests. So that can easily be fixed by changing the configuration limits. You can you can increase the number of concurrent sessions, you can increase the connection pool size. This
So
JDBC
this detail, this insight, developers give you, or how do you like? Do you tell them like this is the problem with the connection pool, or
they will not, developers will not tell. So that's where the performance engineering mindset comes in. So that's why this is a premium skill also, right? Performance engineering is a premium skill. I always keep telling this because when
there are a
people
lot of
run,
things you have to look at. It's not
exactly,
for a developer, it is just writing the code, but
it's a premium skill. That's why I always tell performance engineering is a premium skill, because there's a difference between performance tester, how performance tester thinks, and how a performance engineer thinks. Performance tester will be like, hey, look, I ran the load, I'm getting 500 errors, and he might raise a defect, and he says my job is done. He will assign that defect to developers. So that's what performance tester does. But performance engineer goes to the next level. Okay, he will be like, okay, we got 500 errors. So let's find out what is the root cause. He might open server statistics first. There's a systematic approach that we need to follow. So first, always we start with the hardware capacity. How is the hardware doing? Is the CPU good? Memory good? If the CPU and memory is good, then we know that, okay, hardware is looking good. Then it could be application level issues. And then we go to the application level. We check, we go to the logs, right? When we're getting 500 errors, we might go check the application logs and find out why we're getting that error. It can be sometimes when we're doing that root cause, we call it root cause analysis. When we're doing that root cause analysis, we might find application configuration related errors. Then we know that, hey, okay, because of this error, the configuration is not done properly. That's why we're getting 500 errors. So we tell developers to make that change. They make that change. Of course, we will have multiple discussions. Even if the developer is also convinced about whatever change we are recommending, if he is also convinced, only then he will make it. Right?
Yeah.
And that's how it works. We make the change, we test it again and see if that goes. If application is also doing good, we might need to check. So basically, for a performance engineer, we should know the tech stack. When we say tech stack, whenever we are working on one application, we should know all the touch points, how the request flows. We should know all the touch points. The first touch point can be a UI. And after the UI gets hits, the UI might send hits to APIs. The UI might send hits to database directly. And there might be a front end we might have only one front end UI, but at the back end, we might have multiple applications and different
there
requests.
Can be like series of requests, right?
Yeah, it can be series of requests, or it can be parallel request also. Sometimes in modern day applications, we are building, we are not building monolithic applications. We are building microservice based applications. So when we say microservice based applications, in one request coming from the UI can go to multiple applications in the background. All these applications are microservices. So when we are testing, if we want to debug those performance issues, we should know for, let's say you're testing 10 scenarios. For all these 10 scenarios, you should know how the request flows, which components it touches. We should
So
know. Once
how do you get that information, like flows?
we get that design documents access and all, right? When we are doing planning, performance testing planning, we get we get architecture design documents where we will know all the components, and we also get the sequence. We also have like sequence diagrams and all. Sequence diagrams will tell how the data flows. So these technical documentation, as a test lead, as a performance test lead, we will be reading all this documentation before we start the project.
And
So we
these
know
documents are prepared by the architect, right? Application architect, or say, application.
yeah, architects or lead developers,
Okay.
they might prepare. This architecture diagram will be there, which will be very high level architecture diagrams, and we have more low level requirement specifications documents, and sequence diagrams, data flow diagrams will be there. Data flow diagrams and sequence diagrams will be very useful for us, because those documents will tell us for every request how the request flows, what components it touches. The more knowledge we have on these things, debugging performance issue becomes easy. Let's say you're testing a scenario, and if you know that this scenario first touches component A and then touches component B and then touches component D, then you can first go to component A, check the logs, then go to component B, check the logs. You're getting it, right? So if we don't know the sequence flow, it becomes challenging. We have to randomly check for the logs and scan for errors, and based on errors we can still debug. It takes a bit time, but if we know the tech stack, it becomes easy. That's why I always tell my team to know the tech stack first. They should know how the request flows, then it becomes easy.
Just last question on the salary structure. Like in India, how is the salary for the performance engineers and testers, and in Australia as well? I know that, but just for the audience purpose.
Look, India, I'm not into that recruiting and all. So, and India, I'm not in touch.
Okay, that's
we
fine.
migrated to Australia like 10 years back. I'm not monitoring Indian market, and I'm not involved in hiring in India as well, right? So I don't know, but Australian market I can definitely tell. So for junior resources around 100,000 you can easily get. Up to five years experience you can easily get 100K. And for senior resources with performance engineering, and if you're doing a lot of performance architects roles and all, we can even go up to 160, 170.
Okay.
I'm talking about the permanent roles. Yeah. And for contracting roles, people are getting, it ranges from, again, whether you're a junior resource or a very senior resource, it ranges from 750 to up to 1,000. And there are government projects who is even giving 1,200 per day as well for performance engineer, like Canberra projects and all. I know a few people, they're getting that 1,100, 1,200, but those are contract roles.
Yeah, contract is much higher generally.
Yeah, they pay around 750 to, see, average might be around 750 to 900 mark, but there are very few clients, especially these government clients and all, they might pay up to 1,100, 1,200 if you're really experienced.
I think that's it from my side. It was great talking to you. Hopefully we'll catch up soon. Whenever you come to Brisbane, don't forget to.
Sure. I haven't been to Brisbane. Maybe I should visit once. I keep thinking we should migrate to Brisbane because of good weather.
Okay.